Good day. Let's walk through another data analysis scenario today, right? So the marketing department has spent 10,000 US dollars on Facebook, Instagram, and X, formerly called Twitter, each. They spent 10,000 in advertisements using the same ad, and then they gave me, the resident data analyst, the data about the ad spend in order to analyze the outcomes of the ad spending, right? I've already done most of the analysis in Python, but I'll walk through it with you in Excel just to demonstrate a bit of my thinking and my processing in Excel. So let's open that up. So the marketing data CSV. We would want a bit more space. Control Shift plus plus. All right, Control Shift plus plus. Maybe another one, and then from here we can give this a title. Yeah, marketing cam campaign data. Right, cool. And then off with the grid lines. All right, off with the grid lines. Let's just keep that first. Alt W V G. Lovely, no grid lines. And then from there, let's turn this into a table. Control A, Control T. The table has headers. Bit of table design. Just a bit of table design. That's there. And then merge and center. Similar orange. Let's make it white. Let's make it white. Okay. I want Arial. Da, 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 there we go. And then the header must be bold, and then we'll upscale it a bit. And then here, Control A, and then how do you Alt HOI? Alt HOI. There we go. The data looks a much better, much cleaner. You can see this is the customer ID, the channel. We got them through Facebook. You'll see Instagram and X as you go down there, the country, and whether they purchased. 0 represents they did not purchase, and 1 represents they did purchase. I could make a new column to represent the true and false of that. And if they did not purchase, that means the cart value of theirs would also be 0. All right, cool. So that's a bit of dressing up that. And then let's begin a new sheet. And in this new sheet, now we're going to actually do um, the performance overview, like marketing, right? Marketing, performance over overview, right? View. Lovely stuff. So we're going to look at the channel. No. Da, 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 da. Tab. And then we're going to look at ad spend. And then we're going to look at the impressions. Um, what are the channels? The channels are obviously the Facebook, uh, your Instagram, and last but not least, X, which is the other one. And in all cases, we spent 10K on all of them. Mm, 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 mm. Come on. Yeah, there we go. So from this, we can see we got 500,000 people from Facebook, saying that we got this from the dashboard. These are the impressions. These are the number of people who actually saw the advertisement. Would say 500,000 there, 330 and 300,000 here, and maybe 150,000 here. One, two, three. All right, cool. The formatting is a bit off, but I'll definitely tend to that. And then from people actually seeing the ads, the next thing we want to know is how many people actually visited our site, like how many people clicked that ad and visited our site. So we'd have visits. And from the visits, would pull that from the data here because this is the data of all the people who visited. Some of them didn't buy, as you see zeros here, and some of them probably did buy, right? So these are the number of visits we got. And then from visits, Okay. Yeah, let's make this a table. Before I go any further with it, let's just make this a table. Control T, the table has headers, and let's make it to a similar design as its predecessor. I believe it was this one. Let's MNC this. Come on, don't fail me now. Merge and center. That that bold. We were using area, and we'll push this up a bit, right? Not too much, maybe this. Yeah, that looks perfect, right? And so in order to decide how many people, in order to find out how many people actually visited, we would use a count if, I believe. Count if, right? Okay, count if. Why is there no tooltip? Oh yeah, I did not use equals. Count if. There we go. There we go. Count if. And the range in which we will be using for the count if is in the previous sheet here. Yes, we'll be counting using the channels, and I'd prefer to just use that instead. Yes, the entire data range is the channel, comma, and the criteria is based here. All right, that should count as the visits. There we go. From here we can see Facebook led to 12,000 visits, Instagram led to 8,000 visits, and X led to 10,000 visits. And then from these visits, now we want to know how many of these people actually made a purchase on our website, right? We call that a conversion. And to make a conversion, to count the conversions instead, we will need to use a different function, sum if. Hmm. Yeah, let's count the conversions right now. Sum if. Bit of an error, nothing scary. All right, the range, it's the similar range as we did earlier. We'll use this and skip out. Nope, not you, right there. That's about the, yes, that looks almost perfect. It looks just about right. And then the criteria, as usual, it's this. And then the range we're summing over is actually this column of purchases. And why is it this column of purchases? It's because this column is a Boolean 1-0, binary, I mean, where 0 represents the person did not make a purchase and 1 represents the person who did make a purchase. And therefore, the sum of those ones gives us the number of people who actually did make a purchase. So it's a neat little trick I'm borrowing off of binary values. And there we go. And from here, we can now see that from people who saw the Facebook ads, 360 of them actually made a purchase, 440 from Instagram, and 750 from X. Okay, would you look at that? All right, impressions, visits, and conversions. All right, so from the conversions, we might want to know the percentage of people, just a small little calculation, conversion percentage, PCT, which will be the number of people who were actually converted equals to the number of people who actually converted divided by the number of people who actually visited. All right, I notice that my numbers are actually off. Let me format this for a little bit. This is actually money, so where's currency? There it is. These are count values. All of these are count values. So these are just numbers, format cells, number. I would not want decimal places upon them. 0 and thousandth separators is actually what I want to see here. And then these are percentages. Format cells, percentage. I'd rather 1dp. Lovely stuff. And then from here, the other key pressing factor is from conversions, we now want to see, excuse me, the revenue. Like, okay, they did buy, but how much did actually each channel lead to what, how much amount of revenue? And our trusty SUMIF function has to shine again. And right, pressed enter too soon there, but it will have a similar functionality. The range, as we have established earlier, it's right here. Neat little trick. I should have been doing this before. There we go. Nice. and then the criteria back on the original sheet right here, and then the actual summation range is this time the card value function, the card value column, I mean, which tells us the value um, of goods the particular customer paid for, the value that they paid. And from there, press enter, we can see that, yeah, 22,000. This is currency. I should indicate it as such. 22,000 Bula from Facebook in terms of revenue, and yeah, in terms of revenue was generated thanks to the ad spend, and 44,000 thanks to Instagram, as well as 29,000 thanks to X, right? And then from here, we might want the average card value, um, average card value of a customer, which will be equals to that divided by the number of people who actually made a purchase. Yeah, let's go that. Hmm. Suspicious. Let's see. Oh, this is, yeah, I found that suspicious. It is being formatted as a number when it should have been formatted as a currency, and the decimal places we expect 2, symbol P, correct, correct, correct. There we go. Yeah, that actually looks better. That was suspicious. And now we see the average card values. Instagram has the highest card value in average. And so let's tell a data story now. We've made an overview. Now let's just tell a data story to sum all of these findings we're seeing up, right? Like number one, Facebook led to the highest impressions. That's first and foremost, it led to the highest impressions thanks to the 10,000 people ad spend, and it also led to the highest visits, highest impressions and visits, right? But despite it having the highest visits, it's actually the lowest in terms of conversions and almost second lowest in terms of revenue. But despite it being lowest in terms of conversions, it still has 62 bucks in terms of average card value, compared to X, which had 750 conversions, which is the highest, but the average card value is 39. So highest impressions and visits, um, low conversion, uh, middle revenue, as opposed to Instagram, which is the big spender, which is where our big spenders are coming from. So Instagram instead, we have it was the middle ground in terms of the impressions. It was the middle ground in terms of the impressions, but it was the lowest in terms of conversions. In conversions, but despite being the lowest in conversions, it was the highest in revenue. And last but not least, I'm just trying to sum these up. X had lowest impressions, highest conversions, but lowest revenue once again. So in these three cases, what we would learn from here is that, let's say we just want people to know about our website, want to get our website out there to be seen by the greatest amount of people, then our ad spend would then instead would need to bias our ad spend towards Facebook as per this data set here. And if we wanted to get the highest amount of sales, we would bias our ad spend towards Instagram instead. And if we wanted people to try and buy stuff from our website. We don't care if they bought a lot amount of stuff, but if they at least bought something just so that they can get the experience of actually making a purchase on our website, then we would use X because it has the highest amount of conversions. So that is basically the data story we get from this overview, right? And so from these data story, we then have to ask ourselves actual research questions. Okay, the first research question as a statistician I would ask myself is, okay, is there statistically significant um, difference, or is there statistically significant difference between the channel as well as the conversion rate, right? Is there a dependence or independence of them? Let me write that down. Yes, as I was saying, is there statistically significant difference? Let me type it out so that you hear it. Is there a statistically significant difference in conversions between the channels, right? And since conversion is a binary one or zero type of feature in our data set, and we're comparing it to, uh, yeah, the best test to do in order to do that would be a chi-square test of independence, since conversions are a categorical value. Chi-squared test of independence. That is the statistical test we'll use in order to answer that research question. Independence. All right, lovely stuff. And then the second research question I'll ask myself is similarly, let me borrow from here. Is there statistically significant difference in, Control C, let's just make our lives a bit easier. Control V. All right, there we go. Is there statistically significant difference in card size? Now we're looking at the monetary parts and not just the conversions. Card size between the channels. So these are our two concerns, and that's why we have to make research questions about them: conversions and the card size of the customers. And the tool we would use in order to answer this particular question would be one-way ANOVA. Now, in order to do the analysis required in order to answer these research questions, deserves a video on its own, and I'd hate to take up too much of your time, so I will stop this video here. Thank you for your attentiveness. Thank you for your consideration, and please leave any comments you have down below. All right.